welcome to a new video. In this video, we shall discuss relative atomic mass and relative molecular mass. My name is Jama. This is Neo Tisa. We shall discuss relative atomic mass and relative molecular mass. Under the topic we shall discuss, these are the things we are going to look at. Many of relative atomic mass. Our relative atomic mass is expressed. Gram atomic mass, how to calculate relative atomic mass of isotopes from relative abundance. Difference between relative atomic mass and mass number. The relative molecular mass. Definition of relative molecular mass. These are the things we are going to discuss under this topic. The topic is relative atomic mass and relative molecular mass. Let us start with the first one. What is relative atomic mass? The symbol for relative atomic mass is RAN. Relative atomic mass, or you can use A, small letter R. Relative atomic mass. Relative atomic mass, or RAN. What is relative atomic mass? What is relative atomic mass? This is the number of times the mass of one atom of element. The mass of one atom of element is heavier than 1/12. 1/12, that means 1/12. 1/12 of mass of one atom of carbon 12. Please take note. That is the meaning of relative atomic mass. The number of times the mass of one atom of an element is heavier than 1/12 of the mass of one atom of carbon 12. Or you can say in another way, relative atomic mass is the ratio of average mass of one atom of element to 1/12. 1/12. That means 1/12 of mass of one atom of carbon 12. Take note of that. That is definition of relative atomic mass. Is the number of times the mass of one atom of an element is heavier than 1/12 of mass of one atom of carbon 12. Or is the ratio of average mass of one atom of an element to 1/12 of mass of carbon 12. We use carbon as a reference element to determine the relative atomic mass of other elements. Take note of that. We use carbon as a reference element to determine relative atomic mass of other elements. They can ask you, why do we use carbon as a reference element to determine relative atomic mass of other elements? Why? The reason is this. Why? Carbon reacts easily with other elements. That's one of the reasons. With other elements. That's reason one. The first reason. They can ask, why do we use carbon as a reference element or as a reference to determine relative atomic mass of other elements? Why? Carbon reacts easily with other elements. Number two, relative abundance of Carbon 12 is I. That's another reason. The relative abundance of carbon 12 is what? I. That's another reason why we use carbon as a reference element, because relative abundance of what? Carbon 12, this is carbon 12, is what? I. The third one, the third one, the third one is this. With carbon 12, we can get a whole mass number or nearly mass number of other elements. With carbon 12, we can get a whole mass number or nearly a whole mass number of what? Other elements. That means with carbon 12, we can get a whole mass number or nearly whole mass number of other elements. These are the reasons we use what? Carbon as a reference element to get the relative atomic mass of other elements. These are the reasons. Please, you can pause the video and write them down. Carbon reacts easily with other elements, and carbon can be found everywhere you go. That means relative abundance of carbon 12 is very high. That's the meaning. And you can use what? Get a whole mass number of other elements with what? Carbon 12. Those are the reasons we use what? Carbon as a reference element to get relative atomic mass of other elements. Take note of that. And what is another name for relative atomic mass? Relative atomic mass can also be called atomic weight. You can write it down. Relative atomic mass can also be called atomic weight. Relative atomic mass can also be called atomic weight. I won't rub out this definition because I need this. I need this definition. Take note. Relative atomic mass can also be called what? Atomic weight. Take note of that. Let me express this mathematically. Or let me run all this. Hope you've paused the video and you've written this. Let me rub this off. I said relative atomic mass is the ratio of average mass of one atom of one element. That means relative atomic mass is what? Mass of one atom of element over 1/12 of mass of one atom of carbon 12. Take note of that. Please take note of that. Take note of that formula. Relative atomic mass is mass of one atom of element over 1/12 of mass of one atom of what? Carbon 12. Take note of that. Relative atomic mass is the number of times mass of one atom of an element is heavier than 1/12 of mass of one atom of carbon 12. Please take note of that. Relative atomic mass is what? The number of times the mass of one atom of an element is heavier than 1/12 of mass of one atom of carbon 12. Mathematically, we have that relative atomic mass equal to mass of one atom of an element over 1/12 of mass of one atom of carbon 12. Then let's go. How relative atomic mass is expressed. How do we express relative atomic mass? Take note, relative atomic mass is what? Unitless. Take note of that. Relative atomic mass is unitless. That means it is dimensionless. It has no what? Dimension. That means it has no what? Unit. But it can be expressed in terms of AMU, which is atomic mass unit. I said relative atomic mass has no unit. It is unitless. But it can be expressed in terms of what? AMU. That means atomic mass unit. Take note. Relative atomic mass can be expressed in what? AMU. Atomic mass unit. That means I can simply say one atom of oxygen. One atom of oxygen. What is the relative mass of one atom of oxygen in terms of AMU? I can say relative atomic mass of one atom of oxygen is what? 16 AMU. When you have relative atomic mass of one atom, when you have one atom of oxygen is what? 16 AMU. The relative atomic mass of one atom of oxygen. That means relative atomic mass of one atom of oxygen. I can give it in form of what? AMU, which is 16 AMU. Take note. I can express relative atomic mass of one atom of nitrogen as 14 AMU. 14 AMU. I can express relative atomic mass of one atom of what? Carbon as what? 12 AMU. Relative atomic mass can be expressed in what? AMU, which is what? Atomic mass unit. Take note, atomic mass unit. It can be expressed in terms of what? Atomic mass unit. Oxygen, one atom of oxygen can be expressed as what? 16 AMU. One atom of what? Nitrogen, the relative atomic mass can be expressed as what? 14 AMU. One atom of carbon, relative atomic mass can be expressed as what? 12 AMU. Relative atomic mass has no unit, but it can be expressed in what? Atomic mass unit, AMU. Take note of that. Then let's move further. We have this. Take note of this. What is 1 AMU? 1 AMU is the same thing as 1/12 of mass of one atom of carbon 12. Take note of this. Please take note of this. 1 AMU is the same thing as what? 1/12 of mass of one atom of what? Carbon 12. They can ask you in JPEG, which of the following is AMU? AMU, atomic mass unit, is what? 1/12 of mass of one atom of what? Carbon 12. And that 1 AMU, it has been done experimentally. That means I can have 1 AMU is the same thing as 1.66 times 10 raised to power minus 24 gram. It has been done experimentally, and I can prove this, which I will do in this video. 1 AMU experimentally is what? 1.66 times 10 raised to power minus 24 gram. How do we have this? Please add this one in your mind. 1 AMU is what? 1/12 of mass of one atom of what? Carbon 12. And experimentally, 1 ANU is what? 1.66 times 10 raised to power minus what? 24 what? Gram. Let me prove this for you to show that we are right. How do we prove this? We all know this, that when you have 12 grams of carbon contain 6.023 times 10 raised to power 23 atoms. We all know this. 1 mole of any substance contains 6.023 times 10 raised to power 23 atoms. I believe we all know that. For every 1 mole of any substance, the number of atoms that can be found is what? 6.023 times 10 raised to power 23 atoms. It is done in what? If you have the knowledge of stoichiometry, mole ratio, and Avogadro's constant. 1 mole of a substance contains what? 6.023 times 10 raised to power 23 atoms. The number of atoms that can be found in 1 mole of a substance is what? 6.023 times 10 raised to power 23 atoms, which is Avogadro's constant. Since we know that 1 mole of a substance, I'm taking carbon as a substance. In 1 mole of carbon, this is the number of atoms that can be found. In 1 mole of what? Carbon atom. This is what? Number of atoms that can be found. Then in 1 mole of carbon atom, 1 mole of carbon atom contains what? 12 grams. 1 mole of carbon atom contains what? 12 grams. Therefore, 12 grams of carbon contain this what? Avogadro's constant, this number of atoms. Let me repeat myself. 1 mole of a substance contains what? This number of atoms, which is known as Avogadro's constant. In every 1 mole of a substance, you will find Avogadro's constant. This is the number of atoms that can be found. In every 1 mole of a substance, this is the number of atoms that can be found, which is Avogadro's constant. And I'm taking carbon as an example. In 1 mole of carbon atom, this is what? Number of atoms that can be found. And 1 mole of carbon atoms contain what? 12 grams. 1 mole of carbon atom contain what? 12 grams. Therefore, in 12 grams of carbon atoms, this is the number of what? Atoms that can be found. That means 12 grams of carbon atom contain this what? Number of atoms. Let's move. Then I have in 6.023 times 10 raised to power 23 atoms, the mass of what? 6.023 times 10 raised to power 23 atoms of carbon is what? 12 grams of carbon. I repeat myself. The mass of 6.023 times 10 raised to power 23 atoms of carbon is what? 12 grams of carbon. Then, how many grams will be found? How many grams will be found in 1 atom? Mass, let me say, mass, what will be now the mass of 1 atom? 1 atom of carbon 12. Mass of 1 atom of what? Of carbon 12 will contain 12 grams of carbon over 6.023 times 10 raised to power 23 atoms. Listen. Mass of 6.023 times 10 raised to power 23 atoms is 12 grams. Then what will now be mass of 1 atom of carbon? Mass of 1 atom of carbon will be this divided by this. That is 12 grams of what? Carbon divided by what? 6.023 times 10 raised to power 23. Then from here, let's go back to this equation. From this equation, we have 1 ANU equal to 1 over 12th of mass of 1 atom of carbon 12. Then from here, I will do what? This is what I will do. This is what I will do. I will just substitute mass of one atom of carbon 12. This is mass of one atom of carbon 12, which is what? 12 grams of what? Carbon. Divided by what? 6.023 times 10 raised to the power 23. I'll just substitute that to this. That means I will now have 1 ANU equal to 1/12 times of means times. Mass of one atom of carbon. Mass of one atom of carbon is what? 12 grams of carbon over 6.023 times 10 raised to the power 23. And now write, this is this. Mass of one atom of carbon. Mass of one atom of carbon, which is this, times 12 grams of carbon over 6.023 times 10 raised to the power 23. Then from here, what will I have? 12 cancel what? 12. Therefore, I will have one atomic mass unit, one atomic mass unit equal to, I will have 1 gram over what? 6.023 times 10 raised to the power 23. Then from here, I will have one atomic mass unit equal to, if you do your division, we have what? 0.66 times 10 raised to the power minus 23 gram. 0.166. Yeah, 0.166 times 10 raised to the power minus 23 grams. Then from here, we have one atomic mass unit. Take it to a proper standard form. We have 1.66 times 10 raised to the power minus 24 grams. Take note of that. Please take note of that. Please, you can pause the video and look at that. One atomic mass unit equal to what? 1.66 times 10 raised to the power minus 24 grams. Take note of that. That means I can give it in what? Kilogram. That means if it is in kilogram, it's what? One atomic mass unit equal to what? 1.66 times 10 raised to the power minus 27 kilogram. Take note of this. Take note of this. Take note of this. In kilogram, it's 1.66 times 10 raised to the power minus 27 what? Kilogram. Take note of that in kilogram. That means I have this now. What is one atomic mass unit? Prepared student. That means one atomic mass unit is the same thing as 1/12 of mass of one atom of carbon 12. That is the first one. The second one atomic mass unit is the same thing as 1.66 times 10 raised to the power minus 23 gram in gram. Which can also be given one atomic mass unit is the same thing as 1.66 times 10 raised to the power minus 27 kilogram. Take note of this. 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 Please take note of this. Take note of this thing. One atomic mass unit is what? 1/12 of mass 1/12. Let me put 1/12. 1/12 of mass of one atom of carbon 12. 1/12 of mass of carbon 12. Oh, okay. Or one atomic mass unit equal to what? 1.66 times 10 raised to the power what? Minus 24 in gram. Or one atomic mass unit is the same thing as 1.66 times 10 raised to the power minus 27 kilogram. Take note of that. Take this question. Take this question. Okay, let's look at this question. Question 1 to question 4. And before I do this question, let me give you the formula that relates mass of one atom. Mass of one atom together with what? That relates mass of one atom with mass number and AMU. We have this. Take note of this formula. Mass of one atom. One atom one atom of any element equal to number of nucleon times AMU. Take note of this formula. Take note of this formula. Mass of one atom equal to what? Number of nucleon multiplied by what? AMU. What is number of nucleon? Number of nucleon. Number or nucleon number. Nucleon number simply means mass number. Nucleon number simply means what? Mass number. And what is nucleon number? The number of proton and what? Neutron. The number of proton and what? Neutron. That is what? Nucleon number. The particles inside nucleus. The particles inside what? Nucleus. The particles inside nucleus are known as what? Nucleons. The particles inside nucleus are known as what? Nucleon. And nucleon are what? Proton and what? Neutron. The number of proton and neutron together is known as what? Nucleon number. Those particles inside nucleus. The particles inside nucleus are called nucleon. Take note of that. That means we have that formula. Mass of one atom equal to what? Mass number multiplied by what? Atomic mass unit. I told you relative atomic mass unit can be expressed in relative atomic mass can be expressed in atomic mass unit. For example, I told you one atom of what? Oxygen. What is the relative atomic mass? Which is what? 16 atomic mass units. One atom of what? Nitrogen. If you express the relative atomic mass in atomic mass unit, is what? 14 AMU. One atom, relative atomic mass of one atom of carbon is expressed as what? 12 AMU. I've told you that if you can express relative atomic mass in what? AMU. Example, relative atomic mass of one atom of oxygen is 16 AMU. 16 mass number multiplied by what? AMU. Let's look at these questions. Let's look at this question. The question 1 says, if the mass of one atom is 3.32 times 10 raised to power minus 23 gram, then calculate the number of nucleon present in two atoms of the element. That means nucleon means what? Proton and what? Neutron. And proton and neutron means what? Mass number. Number of nucleon means what? Mass number. Number of nucleon means what? Mass number. And mass number is what? A. They want you to calculate what? A. That is the number of nucleon. And mass of one atom is given as what? 3.32 times 10 raised to power 20 minus 23 grams. This is number of one atom. If mass of one atom is given as this, they want you to calculate number of nucleon. A, that is the mass number. Mass of one atom is given as what? 3.32. That means mass of one atom 3.32. Then calculate number of nucleon. That means mass number. From here, mass of one atom, that is 3.32 times 10 raised to power minus 23 gram, equal to number of nucleon, or no, A. 10 times atomic mass unit. One atomic mass unit is given, don't forget, I told you, one atomic mass unit is given as 1.66 times 10 raised to power minus 23 minus 24 grams. I've given you this. One atomic mass unit is what? 1.66 times 10 raised to power minus 24 grams. Therefore, atomic mass unit 1.66 times 10 raised to power minus 24 grams. Then find A. We have A equal to 3.32 times 10 raised to power minus 23 over 1.66 times 10 raised to power minus 24. This one 1, this one 2. I have A equal to 2 times 10 raised to the power minus 23. This one minus, okay, let me write, divide by 10 raised to the power minus 24. Then what happened? Please, what happened? You have A equal to 2 times 10 raised to the power minus 23. Division, we take the word minus, then minus 24. Then you have A equal to 2 times 10 raised to the power, you have this, minus 23 plus 24. You have A equal to 2 times 10 raised to the power 1. Therefore, A is what? 20. That is mass number, nuclear number is 20. But they say in 2 atoms, this is mass number or nuclear number of 1 atom. They now say 2 atoms, that is for 2 atoms. Therefore, you have 2 atoms. The nuclear number of 2 atoms will be equal to what? 2 times what? A. Therefore, 2 times 20 will give you what? 40. The answer is what? Option C. Option C. Option C. You can pause the video and write option C. Please, option C. Let's move further. The second question. The second question. Very easy. I believe that you will do I will give you question 3 as assignment. You can do it the same way. It's very simple. Please subscribe to the YouTube channel. Please share with your friends. Comment, like, and what you will see WhatsApp link below. If you want to join our online classes and you want live classes, you will see WhatsApp link. You can punch it or press it. It will direct you straight to the WhatsApp group number. Please, you can do that. We need you as you need us. Please, you can do that. Let's move further. Let's go to the second question. Second question. Second question. Second question. Second question. Question 2. We have question 2. Find the mass of 1 atom of chlorine. They say mass. Solution 2. Solution 2. Mass of 1 atom. 1 atom. 1 atom of chlorine unknown. You are given what? A. That means what? Nuclear number, which is mass number of chlorine, or relative atomic mass of chlorine as 35.5. Then you know that 1 atomic mass unit is what? 1.66 times 10 raised to the power minus 24 gram. They say calculate this. And what is the formula? We have mass of 1 atom equal to A times atomic mass unit. Atomic mass unit. From here, mass of 1 atom unknown. You have mass of 1 atom unknown, of 1 atom unknown, equal to A is given as 35.5 times atomic mass unit 1.66 times 10 raised to the power minus 24. You have mass of 1 atom equal to this time days will give you 58.9 times 10 raised to the power minus 24 gram. Yeah, this, yes. Then from here, take it to a proper standard form. That means you have mass of 1 atom equal to, move like this, you have 5.89 times 10 raised to power times 10 raised to power 1, yeah, times 10 raised to power minus 24. Then this will give you 5.89 times 10 raised to power minus 23 gram, which is approximate 5.9. Option what? B. Option B. Option B. Option B. There's another way we can do this. There's another way we can do the first one. We can use the formula. You can try the formula on your own. The formula is this. The formula is this. The formula mass over molar mass. Molar mass equal to number of atoms. Number of atoms over Avogadro's constant. And don't forget, I told you Avogadro's constant equal to 6.023 times 10 raised to the power 23 atoms. Take note, that is Avogadro's constant. That is it. If you try this formula, you will get this. You can use it for this. It's the same, you will get. If you don't want to use this formula, if you don't want to use this one, you can use this formula. Let me try it. Then you try it for this one. Look at this one. You have mass. It's given us 3.32. That is 3.32 times 10 raised to the power minus 23 over molar mass. That is nuclear mass number. That means nuclear number. Number of nucleon. That means mass number. That's what you are looking for. You are looking for molar mass. That means unknown. Because of number of atoms. How many atoms? One atom. How many atoms? One atom. That means this one is what? Mass over Avogadro's constant. 6.023 times 10 raised to the power 23. What happened? You have 3.32 times 10 raised to the power minus 23 times 6.023 times 10 raised to the power 23. Because of this one and this n. What happened? From here, what happened? This one times this one will give you 19.98. What happened? This cancel or this equal to n. Then approximate we have n equal to what? 20. But they say 2 atoms just multiply by what? 2. You get the same thing. You can also use it for this. You can also use it for mass of one atom. One atom. Avogadro's constant. This one they say calculate the mass. This one is unknown. Molar mass is what? 35.5. Molar mass is 35.5 for this one. Then this one is unknown. They say calculate mass of one atom. Number of atoms, 1. There you get it the same thing. Please take note. Please take note. And this one is also the same. They say the mass of one atom of oxygen. They want you to calculate mass of one atom. Okay, the mass of one atom of oxygen is this. They gave us the mass of one atom of oxygen. Find the relative atomic mass in AMU. Let me quickly do it. You can use any one of the two formula. Any one of the two, you get the same thing. Any one of the two, you get the same thing. You can use any one of the two, you get the same thing. You can use mass of one atom equal to mass of one atom equal to A times atomic mass unit. Or you can use mass over molar mass equal to number of atoms over Avogadro's constant. That means you are given mass. This mass is given as this. Then they want you to calculate relative atomic mass A. Then AMU. You know AMU is this. They want you to calculate A. Or you can use this. Let me use this to get the answer. Mass is what? Mass is 2.65. 2.65 times 10 raised to the power minus 23. They want you to get molar mass unknown equal to number of atoms. One atom. 1 over Avogadro's constant times 10 raised to the power 23. Then from here, this one multiply this one we have 2.65 times 10 raised to the power minus 23 times 6.023 times 10 raised to the power 23 equal to this one. And what happened? This cancel this. You have this one times this one. You have 15.89 equal to n. Therefore, approximate, you have what? 16 equal to what? N. That means relative atomic mass in what? In atomic mass unit. Relative atomic mass in atomic mass unit is what? 16 AMU. Option A. Option A. Let me do the last one. Let me do the last one before we move to the next thing under this topic. Let me do the last one. the last one, the last one, the last one. The last one is number 4. Number 4. That was the last one. Number 4. Number 4. We have an atom is 10 times heavier than an atom is 10 times heavier than 1/12 of mass of a carbon-12. The mass of the atom in AMU is, let's say an atom is 10 times heavier than 1/12 of mass of carbon-12. 10 times heavier than 1/12 of mass of one atom, of mass of an atom, of one atom of carbon-12, one atom of carbon-12. So now say the mass of the atom in AMU is, that means that 10 times 1/12. Mass of one atom of carbon-12 is what? Times 12. Times 12, that's mass of carbon, one atom of carbon. That is 12 cancel what? 12. What do you have? The answer is what? 10 AMU. The answer is what? Option A. Option A. Option A. Please, option A. Take note of that. Option A. Please, let me quickly talk on gram atomic mass. Gram atomic mass is expressed in gram. Relative atomic mass can be expressed in what? Atomic mass unit. But gram atomic mass is what? The unit is given as what? Gram. While relative atomic mass can be expressed in atomic mass unit. This is what I mean. When you have relative atomic mass of one atom of oxygen is 16 AMU. While gram atomic mass of one atom of oxygen is what? 16 gram. Take note. This is gram atomic mass of oxygen. This is relative atomic mass of oxygen, of one atom of oxygen. Gram atomic mass. Gram atomic mass. Relative atomic mass. For one atom of oxygen, 16 AMU. For one atom of oxygen under gram atomic mass is 16 gram. For one atom of nitrogen under relative atomic mass is given as 14 AMU. Nitrogen. Relative atomic mass of nitrogen under relative atomic mass is given as what? 14 AMU. But gram atomic mass of nitrogen, of one atom of nitrogen is 14 gram. Take note. Relative atomic mass of one atom of carbon is what? 12 atomic mass units. Relative atomic mass of one atom of what? Carbon is 12 atomic mass units. The other gram atomic mass, the gram atomic mass rather of one atom of carbon is what? 12 gram. That was just the difference. Gram atomic mass is what? Expressed, the unit is gram. While relative atomic mass is given in what? Atomic mass unit. In the next video, we shall look at how to determine relative atomic mass from what? Relative abundance. That is the next video, from relative abundance. We are going to look at how to determine relative atomic mass of isotopes from relative abundance. Please don't forget, press the subscribe button, like, share, comment. You are free with us, and you can call any one of those numbers on the WhatsApp link below. Thank you.